Hello everyone, my name is Isaac Wedig and I'm a PhD student at Michigan Technological University and I study in the Department of Kinesiology and Integrative Physiology. Today I'm going to be talking to you about some work that my colleague Benjamin Cockfield and I have done investigating a new type of physical exercise that we think may be beneficial for astronauts to use in space. So in their strategic plan, NASA emphasizes that one of their major goals is to expand the boundaries of human space exploration, including landing humans on the surface of Mars. But one of the greatest obstacles to longer duration space missions like going to Mars is the negative effects that microgravity have on the human body. And these include decreases in muscle mass, decreases in endurance, as well as decreased strength, each of which can compromise astronaut health, safety, and productivity on missions. And so exercise serves as a very critical countermeasure to mitigating these negative effects. However, in space, astronauts have very limited time, they have very limited amount of room on board space vehicles, and so we need new exercise modes that are very time efficient, very effective, and that use minimal equipment. So many authors have proposed the application of a certain type of exercise called blood flow restriction, or BFR. And what BFR is when exercise is performed with the application of a pressurized cuff or a tourniquet to either the upper leg or the upper arm. And what this does is it compresses the blood vessels at that site, and this reduces the amount of blood that's able to get to the working musculature, and it also restricts blood from leaving that musculature. So in the literature, BFR has been applied to resistance or weight training in both the lower and the upper body. And in both cases, it's been shown to increase muscle size and muscle strength. And the novel thing is that it can do this using weights that are much lighter than traditional weight training. It's also been applied to aerobic training. And in aerobic training, it's been shown to not only increase muscle size and strength, but also endurance. So when you combine BFR with aerobic exercise, you get this very unique 2-for-1 benefit where you get the benefits of resistance training and aerobic training in one mode of exercise. So to date, aerobic training combined with BFR has only been looked at in the lower body and it has not been studied in the upper body. So the purpose of our work is to assess the efficacy of upper body aerobic exercise combined with BFR. And we used an exercise mode in the upper body called arm cycling or arm cranking, pictured here. This is what it looks like in the lab, and so for the BFR, we just apply the cuffs to the upper arm here. And so to address our question, we have two independent studies. Study 1, which we've already completed, and in this study we wanted to just look at the acute effects or the immediate effects of this type of exercise on the body. We also wanted to just do a proof of concept, see if it was a feasible exercise, and also pin down how tightly we want those cuffs to be during the exercise. And so what we found was that arm cranking with BFR is not only feasible, but it's well tolerated. It provides a very robust stimulus to the arm muscles, and we also pin down that optimal pressure cuff. And so after looking at our acute data, we formulated the hypothesis that arm cranking with BFR would result in significant gains in muscle size, strength, and endurance when performed over time. And so to test that hypothesis, our next steps are to complete a training study where we have subjects come into the lab for 6 weeks and they do arm cranking with BFR 3 times a week, and we measure changes in muscle size, strength, and endurance before and after the program to see if it has an effect. So in summary, we found that arm cranking with BFR is not only feasible, it's well tolerated. It may be an efficient way to increase muscle size, strength, and endurance based on our acute data looking at the effect it has in the body. And furthermore, it could be a potentially useful exercise in space. So it's very time efficient. You get the 2-for-1 benefit of both resistance and aerobic training in one exercise. And it utilizes very low loads, so there's a low risk of injury and very little equipment required. Lastly, I'd just like to acknowledge my advisor, Dr. Stephen Elmer, the Exercise Physiology Lab at Michigan Tech, and my colleague Ben Cockfield, and the MSGC for supporting this research. Thank you.